Hi everybody. So in this video, we're going to look at finding the equation of parallel lines. So we'll work through two examples and then we'll try some exam style questions. And if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So in our first question, we're told that we have the equation y equals 2x minus 4, which is this red line here. And we've been asked to find which of these four equations is parallel to this red line. Well, if it's parallel, then it will have the same steepness, which means the gradients will be the same. And this positive 2 is the gradient of this red line. That means every time we move across by 1 in the x direction, we move up by 2 in the y. Okay? So the question is, which of these four equations have a gradient of 2? Well, you can see for equation A, we have a gradient of negative 2. So this wouldn't be parallel. And then for equation B, we've got 2y equals x plus 2. But what we need is in the form of mx plus c, where we can identify the gradient. So if we divide both sides by 2, we'll get y is equal to a half of x plus 1. And what we need is a gradient of 2, so this is not parallel. For question C, again, we'll divide both sides by 2. So y will equal x plus 3. What we need is 2x. So again, not parallel. And then for question D, or equation D, we can expand out the brackets and we get y will equal 2x plus 2. So this 2 tells you that the two lines would be parallel. They would have a different intercept. So for instance, question D, equation D would go here, and it would look something like this, which is parallel to the red line. I'll just move this intercept value up here. Okay, let's try example 2. So in example 2, we've been asked to write down an equation for the line that is parallel to y equals 3x plus 2, this red line here, and passes through the point 0, 1. So if we mark this point on the grid, this would be about here. We know the line is parallel to this red line, and it will pass through the value 0, 1. So because they're parallel, they'll have the same gradient. So the gradient of this blue line will be the same as the gradient of a red line. So we'll have y is equal to 3x plus a constant. And we need to find this constant. But we're told that when x is 0, y is 1. So y will be equal to 3x plus 1. And that will be the equation of this blue line. Okay? Let's try another example. So for question 3, the graph shows two parallel lines, L1 and L2. L1 has the equation y equals 6x plus 9, and L2 passes through the point 4, 26. We need to find the equation of this line L2. So perhaps you want to give this question a go yourself. Okay, so how did you get on with that? Well, for L2, we know the two lines are parallel, so this will have the same gradient as L1. It will have a gradient of 6. So y will equal 6x plus an intercept c. And we need to find this value c. And we can work this out using the x and y values from our norm point. We know x is 4 and y is 26. So we can substitute each of these two into our equation. So y will be 26. This will be 6 multiplied by the x, which is 4, plus c. So 26 will equal 24 plus c. Therefore, c must equal 2. So the equation of L2 will be y is equal to 6x plus 2. Okay? How did you get on with that? Let's try another question. So then we've got examples 4 and 5. In example 4, we're told that the line passes through 3, 1 and is parallel to y equals 5 minus 2x. we've been asked to find the equation of a line. And then for example 5, we've got the standard equation of a line. It passes through a point 4,3 and is parallel to this equation here. So do you want to try these questions yourself? You can pause the video, and when you come back, we'll go through the solutions. Okay, so welcome back if you're ready to go. So for example 4, we know the line will be parallel to this line, so it will share the same gradient. So we'll have y equals negative 2x plus the intercept c. We can work out c by substituting in this value of x and this value of y. So 1 will equal negative 2 multiplied by the x plus c. So 1 will equal negative 6 plus c. So therefore, c must equal 7. So the equation will be y equals negative 2x plus 7. You could also have written y equals 7 minus 2x. Okay? For example 5, well, we know the line will be parallel to this line, so it will have a gradient of 5. So y will equal 5x plus c. We've got x is 4 and y is 3. So 3 will equal 5 lots of 4 plus c. We can work this out as 20. So 3 will equal 20 plus c. We'll take away the 20 from both sides. So c will equal negative 17. So m will be 5 and c will be negative 17. And this will be the equation of a line. Okay? Let's try one more question. Okay, so finally, in example 6, we're told that a triangle has vertices A, B, and C. P is the midpoint of AB, and Q is the midpoint of BC. We've been asked to prove that P to Q is parallel to A to C. So do you want to try this question yourself? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So P is the midpoint of AB. If I draw the line A to B, we'll mark on a midpoint as P. I draw the line B to C and mark on a midpoint Q. What we're trying to show is that the line P to Q is parallel to the line A to C. Now, if they are parallel, they will share the same gradient. So we need to work out the gradient of each of these two lines. But to do this, we need to work out the points P and Q. Well, for P, this will be the midpoint of A to B, or the average X value and the average Y value. So the average X will be the sum of the two X values, 1 and negative 3, divided by the sample size of 2. So we'll have negative 2 divided by 2. This will have negative 1. And then the average Y value will be the negative 6 plus the 4 divided by 2. So negative 2 divided by 2 will again be negative 1. So at P, the coordinate will be negative 1, negative 1. We'll do the same for Q. The average X value will be the 1 plus the 5 divided by 2. So this will be 3. The average Y value will be the 4 plus the negative 2 divided by 2. So this will be 1. So at Q, we've got the point 3, 1. I'll label this on our diagram. So now to work out the gradient of P to Q, we'll have the change in Y divided by the change in X. The change in Y is from the 1 to the negative 1. This is positive 2. and the change in x is from -1 to +3. So this is a change of 4. This would give us a gradient of 1/2. And then for the gradient a to c, the change in y will be from -6 to -2. So the change in y will be 4, +4. And the change in x will be from -3 to +5. This will give us a change of 8. And this simplifies to make a half. So you can see the gradient p to q is the same as the gradient a to c, which means they must be parallel. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.